Welcome to this new lecture of Computer Vision with Deep Learning. In this lecture, we will learn pooling layer, which is used in CNN. It's mean convolution neural networks. Convolution layers in a convolution neural network summarizes the presence of features in an input image. A problem with the output feature maps is that they are sensitive to the location of the features in the input image. One approach to address this sensitivity is to downsample the feature maps. This has the effect of making the resulting downsampled feature maps more robust to change in the position of the feature in the image, referred to by the technical phrase local translation invariance. Pooling layers provide an approach to downsample feature maps by summarizing the presence of features in patches of the feature map. Two common pooling methods are average pooling and max pooling that summarize the average presence of a feature and the most activated presence of a feature respectively. This means that the pooling layer will always reduce the size of each feature map by a factor of 2. For example, each dimension is halved, reducing the number of pixels or values in each feature map to 1/4 the size. For example, a pooling layer applied to a feature map of 6 cross 6 dimension will result in an output pooled feature map of 3 cross 3 feature map. The pooling operation is specified rather than learned. It means pooling layer is not learnable. It only half the dimension of feature maps. Two common functions used in the pooling operation are average pooling. Average pooling actually calculates the average value for each patch on the feature map. Patch is a small part of a feature map, or a part or a window of feature map. Maximum pooling, or also called max pooling. Max pooling layers calculate the maximum value for each patch of the feature map. Now we first discuss average pooling layer. 2-dimensional feature maps, pooling is typically applied in 2 cross 2 patches of feature map with a stride of 2 cross 2. 2,2. Average pooling involves calculating the average for each patch of the feature map. It calculates the average pixel values in a specific window or patch or a part of feature map. This means that each 2 cross 2 square of feature map is downsampled to the average value in the square. Next, now we do an example to understand the concept of average pooling or max pooling layers of convolution neural networks, or we see how to work these layers in convolution neural network. So in the first cell we import the required libraries. First we import the sequential class, and second we import the convolution 2D layer in con 2D class, and then we import the average pooling 2D class from layers package, and at the end we import the numpy array and its function as array function of numpy, and then we run the cell to include or import these libraries. Now we define our dummy data set. Suppose that this is an image, or you can also say these are the values of pixel values of some image. So we store this image in data in list form, and then we convert this list into numpy array by using as array function of numpy, and again we store in the data variable, and then we reshape our data or matrix in this format. Actually this format is also called a tensor. A tensor consists of four values. It's mean first value represent the number of data samples, and second number of rows, width and height, and then this is the channel of our data or our input image, and then we show, and after reshaping, then we show the shape of the data. Okay, this is the shape of our data. In the next line, we create a model by using sequential class. This is our model. It means this is our CNN model. So after creating this model, we add the convolution layer in this model by using add function, and then these are the parameters of the convolution layer. First parameters is filter 1. Please note that order does not matter, and you can also write kernel size parameter first and then filter. So but it is a best order. You can write filters parameter first, and then kernel size, and then activation, and then input underscore shape. This is the shape of our input data, and then we apply on it average pooling 2D layer. Actually, this is the layer. This is average pooling layer. So first we apply the convolution layer on our input data, and after convolution we then apply average pooling layer on our data. So run the cell and see the result. Okay, now we summarize so that we can see the result of convolution layer and average pooling layer. This is the result of convolution layer. In convolution layer, our matrix 8 by 8 matrix decreased by 6 by 6 matrix, and when we apply average pooling, the dimension of matrix is half. So after average pooling, our feature map dimension is 3 by 3. So this is the actually result of average pooling layer in convolution neural network on a data we have already described in the above cells. Define a vertical line detector. So run this. Actually, we have a kernel. Which has following weights, and then these weights we convert in the numpy array, and this is the bias, and then we check weights. Okay, these are the weights, and then these weights store in the model, so that we applies these weights on our input data. Okay, now we apply the predict by using predict method. We applies these weights and convolution and average pooling layers on this. So run the cell. So actually this is our values after one convolution layer and one average pooling layer on our input data. So the first line print the rows, and the second line and the second for loop used for print the column. Max pooling layer. In next we study, understand or discuss max pooling layer. Max pooling, maximum pooling, or max pooling, in general we also call max pooling, is a pooling operation that calculates the maximum or largest value in each patch of each feature map. The results are downsampled or pooled feature maps that highlight the most present feature in the patch. Patch is some specific area of a. The results are downsampled or pooled feature maps that highlight the most present feature in the patch, not the average presence of the features, as in the case of average pooling. This has been found to work better in practice than average pooling for computer vision tasks like image classification. It's mean we often use max pooling layer in image classification task in computer vision instead of average pooling. Now we now do another example which is which explain the concept of max pooling layer. So like previous cell, we also import these classes in our program or code, and then we also again define the data, and then we reshape it, and then this is the reshaped data, and then we create also another model, CNN model, and then we add this model in one convolution layer, and then after convolution layer we add a max pooling layer in the model, and then run the cell so that these are added successfully in the models. And then we summarize these, we check the summary of model, so it is nice. This is the result of convolution layer, and this is the result of feature map of max pooling layer. Now next, define a detector. Its mean detector actually is a kernel, and its size is 3 by 3, and then these are the weights of kernel inside the matrix. So next we add these weights of kernel in the model, store in the models, and then we apply. Okay, now when we model.predict method, actually first we apply these layers on the input data, and then kernel size is 3 by 3. It's mean convolution operation. For convolution operations, they use these weights of kernels, and then now we see the result of these pulling operations. It's mean in our model we have used one convolution layer and one polling layer, and this is the result of our two layers. Actually this is the result of our max pooling layer on our data put. So thank you very much. See you in the next lecture of deep learning with computer vision.